Hello everyone, I'm Colin Kurz, and this is my report for Lab 1. The purpose of this lab was to find the amount of charge held in a strip of charged tape, using both a real-life experiment and a computational model. To accomplish this, a piece of tape was attached at its end to neutral objects and another piece of tape was raised up from beneath it until the top piece of tape started to float. Calculations were performed to discover the amount of charge on the tape. Then, a computational model of this experiment was constructed and used to calculate the magnitude of the charge on the tape. The results of this lab showed that the tape had a significant positive charge. The fundamental physics principle of this lab was Coulomb's law. Coulomb's law states that the net electric force acting on one charged particle due to another is equal to a constant k times the charges of the two particles divided by the square of the distance between them. In this lab, the charged particles were the pieces of tape. The lab also uses Newton's first law of motion, as it relies upon the concept that an object at rest must have a net force of zero to stay at rest. Essentially, the point when the electric force on the tape cancels out the force of gravity on the tape is when the two forces are equal. This fact will be used to find the electric charge of the tape. Before the lab, some mild experimenting with tapes was conducted. Loose tapes were stuck to a piece of tape on a table and then quickly pulled off. It was predicted that these tapes would repulse each other. This prediction was correct. Because the tape was attracted to both neutral objects and a negatively charged pen, it was also determined that the tape had a positive charge. To conduct the main part of the experiment, a few items were needed. Firstly, the two strips of tape themselves, a couple of tall objects, and a ruler. The first strip of tape was placed such that one end of it was stuck to the top of one of the tall objects, and the other end was stuck to the top of the other object. The ruler was placed behind the structure so that measurements could be made. The second piece of tape was then held up to the stationary tape until it moved. At that point, the distance from each piece of tape from the ground at the bottom of the ruler was taken. The measurements were taken at this time because the time right before the tape begins to float is when the forces of gravity and electricity acting on the tape were equal. The distances were subtracted from each other to find the distance between the two pieces of tape. The mass of the stationary tape was calculated by multiplying its length by the provided mass per length of tape. This value was used to find the weight of the tape. Because the electric force pushing up on the stationary tape only had to overcome the weight of the tape to cause it to float, the weight was set equal to the electric force acting on the tape to find the charge of the tape. The charges of the tapes were assumed to be equal so that the Q1 and Q2 in the formula can be combined into Q squared. The resulting charge was divided by the approximate number of atoms in the tape to find the number of deficient electrons per atom. The tape was deficient of atoms because it had a positive charge, as determined in the pre-lab. The computational model essentially followed the same process used to calculate the electric force by hand. It used the values found in the experiment and some derived values, such as weight, to calculate the electric force using Coulomb's law. It also produced the same result, supporting the results of the by-hand calculations. The model showed two equal forces holding the stationary tape at equilibrium, which is what happened in the real experiment. Some important assumptions were taken which may have impacted the calculation of the electric force. It was assumed that each tape was exactly the same length and had the same net charge, which could very well be untrue due to human error. It was also assumed that only electric and gravitational forces were acting on the system, and that each piece of tape could be treated as a point particle. Air resistance did not need to be ignored, since the floating tape is at rest and not moving through the air. Some errors may also have occurred. As already discussed, the tapes may not have been the same length or had the same charge due to human error. The tapes may also not have been held or secured correctly for the charges to interact ideally. Some final questions remain. What if the electrons had positive charge and the protons had negative charge? The only thing that would change is the tape would have behaved differently in the pre-lab. The tapes would still have the same charge, they would just be negative. so they would still have the same repulsive force. Why is it important to handle the charged tapes as little as possible? If the tape is touched too much, electrons from the surroundings can transfer into the tape and cause its charge to become much more neutral. Thus, it was important to touch the tape as little as possible.